So hello, this is Bhavan from Group A2. Our project is on decryption using whale optimization algorithm and particle swarm optimization on two different block ciphers. One is twofish and one is blowfish. So let me take you through the main method of blowfish block cipher whale optimization algorithm. So this is the main method of our code. This is the GUI part of the code. The second part of GUI. The first part is used in creation of virtual machine. I'll talk about that during execution. And these right here, as you can see, these are the functions which we will be using. Time, memory, encryption time, percentage of data hacked, and key optimization time. So let's run our code. So what this is doing right here is creating a virtual machine of RAM 512 MB. The reason we created a virtual machine of RAM 512 MB is because the console in Eclipse actually stops after a certain number of iterations. But in this virtual machine, we can keep on going until the 512 MB is covered. So we thought this was a better method, and we can better optimize our solution. So let's sign up first. So you can give any username. Let's say 12345 6. So it will create a public key and private key for your for your username. So the private key here is 2 and the public key here is 15. All you gotta do is remember your key. Username is 12345 6, private key is 2 and public key is 15. So let's try to execute it again and log in. Yeah, so the username which we entered previously was 12345 6 and the public key was 5 and private key was 14. I guess it's wrong. Let's sign up again. Not an issue. Okay, private key is 9 and public key is 6. Let's log in again. Username was 1234567. Public key was 9. Private key was 6. This should work. Absolutely, it's working. So all we gotta do now is browse a file for the input. Uh, we send this file to a function which encrypts the data and sends the encrypted data into this text file. We selected our file. Let's enter the private key and public key again. Now let's click on upload. So the console here actually responds. It starts responding. What it is doing here is we actually used a random function which creates a set of different iterations of possible key. So what it starts to do right now is starts to generate the key. It arbitrarily generates random keys and checks whether it's working for the encrypted file or not. So yeah, it is done. Uh, so the symmetric key was the last one. So this is the symmetric key which we got, and the encryption time which it took was about 25 seconds. decryption time was about 5 seconds, and the total time taken was 25 seconds. This is in the millisecond scale, so converting 25,826 milliseconds to seconds is divided by 1000, so you get 25 milliseconds. So it will be displayed, the encrypted data will be displayed here. We actually had a lot of bugs. It was working previously. The functions like the time, memory, encryption time, and percentages of data hacked, and key optimization time. Uh, we have to sit on that for some more time. So hopefully we'll make it work. And coming to two-fish encryption using WOA, going to run main.java, executing this. So the process is similar over here. We create a VM again, which is 512 MB. We sign up, and then we log in again. Oh, sorry, I have to sign up, right? Yeah. So the username is 123, and the private key is 2, public key is 19. Let's log in again. The username was 123, public key was 2, private key was 19. It absolutely works. Now we browse for our input file. We chose that in that particular input file was because it actually resembles a bank application. It has about 17 rows and 17 columns and about 4,500 rows. So we thought it will be very good for our testing. So we chose that. So enter your private key and public key again. Click on upload. Here you can see the two fish key is generating. Uh, these are the generated two fish keys. So here we didn't have any trouble, so we are getting our functions here. So the total time taken was 21 seconds. Memory of that particular file was 188 MB, sorry KB. Encryption time was about 8 seconds, and the percentage of data hacked is 1.5%. The percentage of data hacked is small because we just tested our software in a very much difficult block cipher, so we could only hack about 1.5%. The previous one, which we saw, the blowfish using WOA, we were able to hack about 80 to 90% consistently. Like about the file was about 188 KB. We were able to acquire about 146 to 150 KB. It varies from time to time. So coming to PSO, particle swarm optimization, we actually did that, but we got a lot of bugs and all. So we have to correct that code. So currently, currently I'm just putting these two in the video. That's it. Thank you.